awesome part, mathematics, which is the word problems part, right? Exactly, that's right. I should always play after I say word problems. Word problems. Does anybody have any specific questions? I'll tell you this. I've graded a few people's section 3-4 is the word problem section, and so far the people that have turned it in kind of understand what they're doing, which is good. But you forget, you don't stop when you get x equals 11 and stop. What's kind of wrong with that? There's two things kind of wrong with stopping at when you get x equals 11 when you have a word problem. Possibly. Maybe there's more than one piece of it. Maybe it's a rectangle, you're supposed to give me both sides. Maybe there's 3 people and it's the amount of money they each make. So you only got one person, you're missing the other 2. Right? So that's one thing. Also, I'm going to be a complete dork and say 11 bananas, 11 light years, 11 senators from New Jersey in the past 80 years, right? 11 what? So when you say 11, it doesn't mean a damn thing. Right? So the math gets you so far, and then we as the humans have to step in and say, oh, this is what this number means. So you have to put your units in. Some of you guys just got back your section 3-4 homework. You know what I'm talking about? Units, and make sure you answer all the questions. It's a triangle, you probably have to give me 3 sides. Don't give me one number and stop. You guys kind of with me? Okay, cool. Now understand, word problems are the most despised thing in mathematics, and a lot of us just would like to get to a number, period, and just be able to stop there. But even once you get there, you got to go that little extra step further. Now, let me see. I think I had at least one specific question. Yeah.
Chapter 3.4, page 191, 45 or whatever.
Which one?
All 45.
45.
3.4.
All right, let's see. This is the U.S. has the most computers, followed by Japan. So here's what it is. It's on page 194. So take a minute and read through that if you haven't done this already.
I got the answers right, it just don't add up. I don't understand how.
Don't worry, we'll get there.
I have a question.
Yep. Oh, that's part of what I was just asking for. So you got to tell me Japan, and you have to tell me the U.S.
Oh, okay.
To tell me both, yeah.
So, are you going to do it on the board?
Yeah.
Okay. I'll just put it
So it'll be a freebie. This will be a freebie. Okay. So tell me, those of you who have read this over, can you tell me what's the first step? I don't have to draw the U.S. and Japan, thankfully. Yeah, what are the players? All right, careful now. Don't bring any math into it yet. Don't bring any numbers. Don't bring any 7 less than or whatever. So I've got the U.S., Japan. Be a little more specific. What about the U.S. and Japan?
Computers.
The number of computers. Now, I know on one level you guys are probably like, how much of this do I really have to get so I can pass this class? I understand that. And then how much do I have to get to pass the next class? But I desperately want you to understand, the whole purpose, the whole reason that we want you to do as much math as we want you to do when you get a college degree is because this is the amount of math that's a foundational amount that you can then springboard off of. So in the real life, I don't know certain things. In real life, I see something happen. And so a very good example is if everybody wants to be a cop. You're going to use the ideas of algebra all the time, believe it or not. So I make all these observations and I try to kind of put them together. I have little bits of information. I don't know what happened, but I do know the after effects. Right? So algebra is a lot like that. We know the after effects. I have no idea X, what it represented. I have no idea what it was, but I do know what it did. So I got to kind of work backwards. So which one of these is going to be just X? That's step 2, right? Step 1 is pure English. Just write down the words, and then why is Japan X?
Because it's saying the numbers is.
Yeah, the USA has so many millions more than Japan. So I got to know Japan first. So if I know Japan is X, then the USA, how could I write the USA?
162,550.
I love it. So it's X plus 162, what was it? 550. I know it's million after that. Don't put a bunch of zeros after that. Just your answer's going to be in the millions. Don't worry about that. Just put the word million at the end. You'll be fine. Is that cool? Don't worry about putting all the zeros in. That just makes it crazy. And again, a few people that have turned this homework in, they are making the equation based on that. They say that equals something. Well, that's the US by itself. If you skip this step, you will almost always forget that other X. You forget the other dude. You're supposed to do something together, not the guy by himself. So what does this say now?
The total is 318.
Yeah, the total number of computers for both countries is 318,450.
So you do 2x.
Yeah, so the US plus Japan. So I've got to be able to find both
2x.
players in there. And now you just divorce yourself from where this came from. It doesn't matter. Math doesn't care where this equation came from. Forget about this. This is not important right now. Just solve that equation. So a lot of times I think that previous stuff gets in your way. Previous stuff doesn't matter right now. I've got an equation, I can solve it. So you started to solve it for me. You got the like terms. Yeah, this one subtract. So I'm going to let you use calculators normally on these kind of problems, because they don't want the long subtraction form to be the reason you get it wrong. I want to test you on, are you able to do word problems, not are you able to calculate. Don't worry, I'll still test you on that too, but not just all at the same time. So minus 162,550. What do you get when you subtract those?
155,900.
Looks about right.
We'll divide into.
Yeah, and then just divide it by 2.
77,950.
77,950. Okay. So what's that represent?
Japan.
So a lot of people, the mistake they were making was they were circling that and then going to the next problem. Number 1, that doesn't tell me what the hell that is, and number 2, that doesn't answer the question really. So Japan has 77,950 computers. And then to get the US, I just take 77,950 and add on the 162,550. And then whatever the hell that is. 240,500? 240,000? Yes. Million. Don't forget that million. $40,500 million computers. Well, thank you. I was waiting for somebody. How much computers in the world? You guys get that idea? So there's the 2 main mistakes people make, and it really sucks when everything's going really well, and then you either stop there, or you don't tell me what the hell the numbers mean. And that's a simple fix. That's simple. So that's actually a good mistake to be made. If that's the only mistake you're making, that's good. Because normally people, if you have trouble with just the setup or the solving, that sucks, because that's a more basic skill that you need to work on. This is easy to fix. Put the units on. Don't forget to answer both questions. Right? Easy fix. Yeah. So let's number 30 real quick.
Turn it on.
It's on.
Oh,
I just want to make sure where I am.
you're not good at it?
Yeah. So read through number 30 real quick. It's all about elephants and chimpanzees. All right. See about 4 people reading through it, at least that. See, some people are reading through it. So if you've already done this problem, awesome. But as you're reading through it, tell me, what's the first step here?
To identify who, what.
Yeah. So how many players are there? 2. And be more specific when you write it down. If you write down elephants and chimpanzees, you should actually say something about like life expectancy. Okay, cool. A little more specific when you write down what do you mean about elephants. The number of elephants you can fit in your car. You have a car, you got it. So the second step. First step is identify the players. It's a purely English step. Don't worry about the 8 more than twice. Don't worry about the 50,000, whatever the numbers and the stuff. Just worry about what are the players. Second step is start to translate it into math. Which one of these is going to be just X? And why?
Because they gave me info for the elephant.
Yeah, the average life expectancy for an elephant is 24 years longer than a chimp. So the elephant it depends on the chimp. So I got to let the chimp be X first. So the chimp's life expectancy is X years. The elephant is 24 more than that? Yep. So how do I write that?
X plus 24.
X plus 24. And then what are those two things supposed to do?
Equal.
Yeah, the total of these is 130. So if I add the elephant's life expectancy to the chimp, I'm supposed to get 130. And now you don't care about where it came from, you just start to attack that equation. Right? So when I grade these, I grade them in steps. If you got this step wrong, I will then grade you on, did you at least do the solving of the equation you got correct. It's the wrong equation, but can you at least solve it? So I will give you partial credit throughout. Obviously, if you mess up on this step at the beginning, the whole damn thing is screwy. I'm going to at least grade you on, are you able to do the rest of it? So to solve this isn't too bad, right? 2x, I can subtract 24. Yeah, divide by 2. So up here, the chimps is X, so X is 53, so the chimps live 53
More. Years.
53 days, 53 seconds, 53 years. And again, I will be a complete dork. I will say, do these 4 things live 53 seconds? 53 what? 53 millennia? 53 centuries? The chimp's been here. Right, and what about the elephants real quick?
77 years.
Yeah, 53 plus 24. Yes, ma'am. Did you have a question about this one?
Oh, yeah, I put X equals 53 chimpanzees, and you put underline and question marks that made like,
So 2 things. You didn't tell me the units, and you didn't. I don't think you told me the elephants.
oh yeah, I did it.
You did? All right. So maybe you just left out the units.
Okay.
Yeah. Okay. For the one, normally I would put underline and I put and. If you left out the second part.
Yeah.
Gotcha. Yeah. Wait. You've been waiting for a while. Sorry.
18.
Not Wayne. Mark. Wait. What's your Wayne?
Wayne's a better guy. He's the second biggest guy.
Okay. Which one again?
18.
A few more, we'll have this done. Let's see. 18. Oh yeah. So the kind of problems there where number 18 is, that section of homework, this is more very direct translation in the math. There's no like chimps, there's no countries, computers, there's no Olympic medals, there's none of that. It's just straight up, there's one step away from that. So 18 says the product of a number and 3 is, okay, stop right there. All right, the product of a number and 3, how do I write that?
3n equals.
Or 3n, 3x, I like it. Is, I love it. You see is that equals? Twice the sum of that number and 5.
So 2.
Now, this is a little evil. If you write this, it's not right.
Parentheses.
So, what am I twicing, just to make up a
X
word?
plus 5.
What am I doubling? Twice the sum. Good. So I've got to write the sum first before I can double it.
So X plus 5.
Twice the sum. Okay, what's the sum of a number and 5?
X plus 5 here.
Now I need to double that. Bam. Now it's definitely a little bit evil. And I just got to solve that equation. Simple. It's really easy to make a mistake and say 2x plus 5, but then you're doubling x. You're not doubling the sum. You've got to double the sum of a number and 5. You've got to put that in parentheses. And that should be relatively easy to finish out. Yeah.
Maybe 24 on the same page.
And that's next, number 21.
Oh,
Yeah.
24 is the evil one.
Yeah, that one.
Yeah, 24, I crossed through a few of you guys before I remembered that's one that uses that word less. 3 less than a number is this, but 3 less a number is that.
So is it 2x?
So screw 24.
But is it 2x equals 25 minus 3?
24 is 2x equals 25 minus 3x. Yeah. 25 less 3 times the number is 25 minus 3x.
So 2x.
How often do we say that? Now, I really want you to understand why I just said that. I didn't just say that for the shock effect. I said that because we don't use that phrase in English often at all. So why should we worry about translating the math? It just gets in the way. So I should have thrown that number 24 out from the beginning. I just didn't realize they snuck in one of those less. It's not less than, it's less, and that's the evil. That's the extra evil one. Forget about number 24. That's okay. You'll be fine. Yeah, just yeah, good.
Oh, okay. Can you do number 21?
So 21 is a lot like number 18 because it says 3 times the difference of. So I've got to set up that difference before I can triple it, right? So it says 3 times the difference of some number and 5. So I don't write the difference of some number and 5. Yeah, x minus 5 is the difference of some number and 5. Now how do I triple that? It says 3 times that. And how do I do it though? Yeah, that's 3 times this difference, right? If I do this, they should have said the difference of 3 times the number and 5, and that's not what they said. They said 3 times the difference. So I gotta have the difference first, and then I can triple it. And oh yes, that is math grammar. I know. Just can't escape grammar. It's everything. Amounts to the quotient. Okay, amounts to translates. Amounts to translates to equals. You guys got ahead of me. Quotient is division. So divide 108 by 12, and then you just solve that equation. Thank God 12 goes into 108. That's useful, right? Yes, ma'am. Now on these, you still have to solve them. I'm letting you do that. I decided to not do as much of your homework for you. Which one? 27? So read through 27. You're good, man. Read through 27. And what's the first step there? You don't have to draw a falcon. Yeah, so the first step is just an English step. What are my players in this problem? Yeah, the falcon and the snowman. The falcon and the pheasant. And what about them exactly?
Who's faster?
Their speed, right? So the first step really is just English. What are the players involved? Is it Fred and Bob's salary? Is it the size of a triangle? Is it whatever? So here we got a falcon and a pheasant's speeds. Now the next step is which one's going to be just X? Yeah, why? Because the falcon can travel 5 times as fast, so the falcon is something to do with, I got to know the pheasant first before I can do that stuff to get the falcon. So the pheasant is X, falcon is 5 times as fast. No, I appreciate that because you're right, so far it's been that way. It's just, very often you'll do that as you read it because it'll say Bob makes twice as much as Fred. So then Fred's X. But is it always? No, it's not a rule. It's just because of the way we talk. It happens. It happens a lot, but it doesn't always happen. Yeah, I'm glad you saw that. So the falcon's 5 times as fast.
Yeah, 5x.
5x. So falcons eat pheasants. They are pretty much screwed.
Speed together is 222.
The total speed. Yeah, thank you. So if you add these up,
6x equals 222.
you get 222. Yep. I just got to solve that equation. Cool. Yeah. So this is in 3.3. This is the solving equation number 24. Okay. So when you go to solve this equation, any equation, what's your first thing you're looking for? Yeah, parentheses, that tells me where I got to distribute stuff. So what do you get when you distribute this here?
12t.
Good. 4 times 3t, 12t. 4 times 4 is 16. Good. That 4 can't go there also. I haven't seen anybody do that yet. Good. Equals, and all that, I can't do anything over there. 3 plus 5t is not 18. How do you have 18s? I only see 5t's. I get 8. So be careful about like terms is always there. What can you do on this side?
Only the number.
Yeah. 12t, good. The bigger one's negative, so it'll come out negative at the end. And now we're at the step where you just choose which way to go. Okay, cool. You can subtract the 5t, so your t's are still positive. Right? So if you take the t's this way, good, 7t minus 4 equals 3. You better take the numbers the other way. So what's got to move now?
Plus 4.
Yeah, that 4's in the wrong place. So you add 4. 7t equals 7.
T equals 1.
Yep. Divide by 7. Cool. All right. Is any other questions before we? Okay. Trying to figure out. We need to get it in chapter 4. I don't want to get away from 3-4 too quickly, though. A lot of you guys have given 3-4 a try. A few of you just got to make a few little corrections. If you have not gotten to 3-4 yet, you must do so very soon. It's in this class itself, we're not going to have a ton of word problems. This is almost all the word problems you'll see. There'll be maybe a few more every now and again. In Math 90 and Math 103 and 10, that's going to be the focus. You learn some stuff, there'll be word problems associated with it. You learn some stuff, there'll be word problems associated with it. Why do we do that? Because that's freaking real life. All right? So we're trying to get you ready to see how math operates in real life. So continue to go through there. Let me say this before I get too far away. There will be a quiz on Thursday. I'm not going to put any word problems on there yet. There you go. Some of those becoming But it is going to be very focused on solving equations, all kinds of equations that we've seen so far. So it's just going to be very focused on, well, it's going to start with some combining like terms, and then solving equations. No word problems yet. I'll leave those for the test. Okay. So what we're going to do now is we're going to get into chapter 4 a little bit. Yeah. Yeah. And I really just want to start off and see how much we already know about these things. We've already seen fractions this semester. They've shown up every now and again. Some of you guys long divided and wrote your remainders as fractions, which is awesome. But I want to start with something kind of basic here. You know, you always have the pizza pie and all that kind of crap. So, you know, you use the pizza pie and you cut it up into pieces and you eat pieces and you see how much is left. What about if you're driving along in your gas tank? And your gas tank basically has, make it very basic. That looks like very exciting. All right. Anyway, so here's empty, here's full. And it's broken up into 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So how many total little tick marks are there? This is 0, so this is 1 through 15. I love it. So far, so good? So if I am right here, what fractional part of my tank has gas in it? What fraction represents my water? So we can look at it a few different ways. How many total, on the bottom could be 15, because every little tick mark is 15. So how many little tick marks do I have? 5, 10. Now how else are you guys looking at that? Oh, we got a little dissension. So remember, this is 0. So this is 1, 2, 3. All right, so how full is this thing? Another way to look at it is 2/3. Right? This is also 2/3 full. And normally we do have to consider our gas tanks. And normally we do hopefully think about them in these terms every now and again. How much gas do you have left? So forth. Right? You at least know when it's half full. And then you know when it's really close to E and you're like, I'm right on vapors. Where's your freaking gas station? But another way to look at this is it's 2/3 full. And I don't count this tick mark because it's freaking 0. I don't have any gas when it's there. So I don't count that guy. This is 1, 2, 3. So these must be equal to each other, shouldn't they?
Yeah.
They have to be, because they both represent the same situation. They can't be two different things. That's freaky. My car has this much gas and this much gas at the same time. What the hell? So these must equal each other somehow. Why do they equal each other?
This 5 goes into 10 twice. And
Yeah, you can divide the top and bottom here by 5, and that's a process known as
reduction.
reducing. I love it, reduction. So if you divide by 5, you get 2, divide by 5, you get 3. There you go. So there's a physical representation of reducing. Why does reducing make sense? Because it makes sense, physically it makes sense. Okay, step number 1. So in this homework, you're going to see a lot of, the other thing I was thinking about doing would be like, let's see, I hate eggs, but I'm going to think about Cadbury eggs. Say I had like a Cadbury egg carton. Are you seeing these things? Just really got to be careful because you can eat half of them on the way home. So not careful. Going to a sugar coma. But let's say I have, I've eaten several eggs I've got eggs there. That's how many eggs I got left. So what fractional part of the carton do I have left?
2/8.
Or 1/4.
Sorry. These are where I have it left. These I've eaten.
Oh.
Yeah, so I got 6 out of 8 left. Cool. Which will also be, now if I pick that guy up and put him here, I could look at it like this.
3/4.
That would be 1, 2, 3/4. And that's very similar to what we did up there. Because 6/8 reduces to 3/4. If you divide the top and bottom by 2, don't you get 3/4? So physically, again, if it reduces, there's got to be some corresponding physical representation of that. I can look at it as 1, 2, 3 out of 4 parts of it that are full. That's 3/4 full. Full. Okay. So then what about mixed numbers? Mixed numbers would be if I have
Whole and fraction.
This is exciting, Jen. Whew. So how many cartons of eggs do I have? How many eggs do I? What fraction would represent the number of eggs I have left?
2 1/4.
Yeah, I've got 2 full cartons. That's why it's called a mixed number. That's the whole part of it. I've got 2 full cartons and
2/8.
2/8.
1/4.
so also known as 2 1/4. Yeah, because I can put that egg there, and then again it's one out of 4 sections, right? 2/8 is the same thing as 1/4. So all a mixed number is I've got more than one whole thing. I've got more than one. Right? And it's called a mixed number because it's a whole part and a fractional part. And normally in English, when we say fraction, we mean like a real, true fraction. A proper fraction. So what's an improper fraction?
Where the numbers.
4 over 1.
Yeah, where the top is bigger than the bottom. That's not really a fraction then. If I say I make a fraction of the money that Bill Gates makes, I don't mean I make 27 over 3, because that's 9. I don't make 9 times as much as Bill Gates. Right? Even though you've Prop 30 passed. I don't make that much money. Fraction, when we say fraction in English, we normally mean something less than 1. I make 1/4. In this case, I make 1 billionth. Right? So, another way to write this then is to look at, sort of like what we did here, look at the little tick marks instead of looking at each section. I can look at each little thing. I got 8, 8, 8. So how many total spots do I have? Yeah, I've got 24 spots. And how many total eggs do I have filling those spots? Yeah, I've got 8, 16, 18. Cool? So I could look at it like that. That's one other way I could look at it. But how do I make this into an improper fraction? Let's take this here.
You will multiply the whole with the denominator and add the numerator.
Yeah, let's see how much. You guys remember how to make this? It sounds like a few of you guys do. You do 4 times 2 plus 1. Good. So you get 9 fourths. Is that cool? And what does that really mean here? Get rid of that guy. 2 1/4. What's another reason why that works that way? I mean, do you guys remember why it works that way? If you go the other way around, if I started off with like 11 over 6, how do I make that into a mixed number?
Multiply 11 by 6.
Good. You actually do what it says. You divide 6 into 11, and it goes in
One time.
once with 5 left over, right? So that's 1 and 5, 6. Now here's another way to do this, and you don't suddenly have to start doing it this way, but this is a really cool way to look at it at least once. 11 over 6, I can rewrite 11 as anything that is 11. I can rewrite 11 as 10 plus 1, I could rewrite 11 as 20 minus 9. You with me? We normally wouldn't do that. We normally go the other way. We normally make things easier. But I could rewrite 11 in this case. I could rewrite it as 6 plus 5. You guys kind of with me? Because 11, why doesn't 6 go into 11? Because it's got extra stuff in it. It's got 5 extra things in it. So I can look at it like that. I could say, okay, I got 6 over 6 plus 5 over 6. And this is your 1. Or 6 divided by 6 would be 1. And there's your 5, 6. Okay, that's another way to kind of look at it.
It's longer.
It's longer, good. But that's why I said you don't do it that way normally. But that's another way to make it make sense why we do what we do.
So if you didn't split 11 as 5 and 6, would the answer come out the same?
This is the only way they can actually reduce it correctly, right? Some other ways would work, but it would come out with something that would have like a negative fractional part, and we don't want to go there. Yeah. Cool.
So the way you got the top one, you did 4 times 2 plus 1?
Here. Yeah, so the shortcut to going the other way, thank you. So I wanted to remind you guys how to go this way with it. Now why does it make sense going the other way? Why would you do 6 times 1 plus 5? Because here it's telling me I've got 5 extra. So I got, let me see if I can make this make sense. Here. This is a 1 because 6 went into this at least once. So I have at least 6 plus 5 extra. So it's that 5 extra that kind of helps us figure this out. So if I have 1, that could be 8 eighths, that could be 4 fourths, that could be anything over something. So if I have 1 and 1 ninth, then I have 9 ninths plus an extra 1. So really, where did that 9 come from? 9 times 1 is 9. I can always make 1 as 9 over 9, or 12 over 12, or whatever. So it's adding in that extra 1 that gives me that improper fraction. That'll be 10 ninths. 1 and 1 ninth is also known as 10 ninths. It's 1 ninth more than a full 9 ninths. How are we doing with that so far? Okay. Normally where we have trouble with fractions is when they start creeping into other things, like they start creeping into equations, or they start creeping into other calculations that we have to do. So let's do a couple of just straightforward, no concept, straightforward calculations. Let me give you a few to try. Try those real quick. So the nice thing about rewriting as a mixed number is it's really just doing what it says. This does say fundamentally 11 divided by 4. So you just carry that out. The reason I gave you that other way to look at it is so you realize what's really going on. There's a few different ways to make this quicker. 4 does not go into 11, but 4 does go into 12. So the answer should be something close to 3. 11 fourths is just barely less than 12 fourths, right?
Right.
So the answer should be something just barely below 3. In fact, exactly how much below 3? 1/4 below 3. Isn't 11/4 a quarter less than 12/4? And one thing you got to really start getting used to with fractions is, it's almost the same thing as saying 11x and 12x. I have 11/4 and I have 12/4. So how much bigger is 12/4? It's 1/4 bigger. It's like me saying how much bigger is 12x than 11x? It's 1x bigger. So 12/4 is 1/4 bigger than 11/4. You guys still kind of with me? And again, a lot of what I do up here is explain concepts. This does not translate into, holy crap, how am I going to do this in my homework? No. This is me explaining the idea. All right, the nuts and bolts of how you do it will be much simpler, much more direct. I'm just trying to make it make sense. So one way to do this is just to kind of reason it out. It's almost 3, so it should be 2 in some fractional part. So if I said, you got a quarter less than 3 gallons. So we know how to make that, how to actually figure that out. How many gallons do you have this? If you have a quarter less than 3 gallons.
2 and 3/4.
Yeah, you have 2 3/4. 2 3/4. Now we're working our way towards that. So we haven't quite gotten fully yet to where we start subtracting fractions and so forth, because like denominators is in our future, right? LCD, least common denominator. So the more direct way to do this is just to go ahead and carry out the division. 4 goes into 11 twice. So far it's matching what we thought here. It should be just below 3 with remainder 3. So 2 3/4. Another way you can always do this is, instead of going up to 12, go down. 4 doesn't go into 11, but it does go into 8. And see how that 3 comes into play? How much more is 11 than 8? 3. So it's that extra 3. It's the remainder 3, right? 2 goes into 8, and there's an extra 3 there still. So that gets stuck up here. Cool. Okay, maybe. So I'm giving you several different ways. The most direct way to do it is this way. You can always rely on that. But the further you get, you want to be able to do things a lot quicker. You want to get used to it a little bit better. You got all these other ways you can do that would be quicker if you felt comfortable with it. So doing this one the same way, 5 times, 2 left over, so this would be 5 and 2/5. And again, if we just estimate it, 5 goes into 25 5 times, so 27/5 should be a little bit bigger. In fact, there's an extra 2 there that we see right there, an extra 2 that we see showing up in that fractional part. Cool. Maybe. All right. What about the other way around? The other way around is surprisingly easy. It's much easier to multiply and add than it is to divide and subtract. Right? So that's exactly what we have to do here. And it's really just adding back in that remainder, that extra piece. 8 3s is 24, but I add an extra 1. So it's 25. So you do 8 times 3 is 24, plus 1 is 25. That's why it's not a full 3. To be just a full 3, it should be 24 over 8. Why does it have that 1/8? Because it have that 1 extra. So 25/8, not 24/8. Now I know this is old news to a lot of you guys. I can see the expression on your faces like, move along, Jeff. Hang out. Make sure everybody's on the same page before we move forward. What about this next one then? Yeah, 7 times 11. 77 plus 3. 80 over 7. Notice what always goes on the bottom is exactly what is on the bottom. No need to change the number. Don't get rid of it. Don't suddenly say 3 and 8 is $25. You owe me 3 and 8, so give me $25 for square. No. That over 8 still has to be there. Cool. Okay. Maybe. So, let me try this. Hopefully, most of you guys have your book. That would be useful. Always a good idea to bring the book. I want to give you some problems right out of the homework here. page, page 215. Okay, that's it. Some of these problems are in your homework for this section too, so keep that in mind. You're getting some of that done now. Mine is the night.
So you want us to?
But, let's see. You guys share it? Cool. Yeah, try these problems out. Let me know if you need some help.
No, it's fine, I would just use those.
Do you want us to reduce it or just, it says identify the numerator, denominator, or improper or proper?
Exactly. So
You just
don't
want us to do
reduce it.
that? Okay.
Yeah. If you did also reduce it, that's not a problem.